So in this video, we're going to talk about derivatives of inverse functions. But before we do that, we're going to make sure that we understand what an inverse function is. So recall that a one-to-one function, so one-to-one functions have inverses, okay? So we need to first know that the inverse actually exists, right? And so y equals f of x is one-to-one. What is one-to-one? Well, if it passes the vertical line test and the horizontal line test. If we can pass both those tests, then the function is a one-to-one function. So say we have this curve here. So this curve is sine of x. So clearly this is not one-to-one because I can draw a horizontal line and it passes through infinitely many places in this curve. Now, if I restrict sine of x to negative pi over 2 to pi over 2, all of a sudden this curve becomes one-to-one. It passes the vertical line test and the horizontal line test, okay? So if we make restrictions, then we can say that the inverse is actually a function, okay? So the way I think about inverses, I think about it reflecting across the line y equal x here. So if you have this function here, then the inverse function is a reflection across that, I guess you could call it axis, the y equal x axis, this slanted axis right here. Now you think about it, what's happening here? The x value becomes the y value, and the y value becomes the x value. You're literally swapping x with y. When you're saying y equal x and you're swapping, you're reflecting across the xy line, then you're flipping the x and y values there, okay? So if f is one-to-one, so if we know that the function is one-to-one like we have here, then it has an inverse denoted by f inverse. So this is not f raised to the negative 1. This does not equal 1 over f. Okay, that's not what that's saying. All right, it's not the inverse derivative or whatever. F inverse is the inverse function. That's the notation. Probably some of the worst notation in math, but you know, that is what it is. Okay, such that f of a equals b. All right, then the inverse, f inverse of b is equal to a. So let's show this in a mapping. Okay, so how does this work in a mapping? So say I have some set A and I have some set B, okay? So what f does is it takes the elements that are in A and then it maps them over to B, okay? So f is a function that takes A and puts it into B, right? The domain of f is A, right? The range of f is your B over here. Okay, so the inverse function, what this does, this is like the anti-function, okay? It literally does the opposite of the original function. So instead of taking A and mapping it over to B, it's going to take B and map it over to A. So you input a B and it maps it over to A, okay? So the domain of the inverse is the range of the original function, and the range of the inverse is the domain of the original function. You're literally swapping your x's and y's. When you're talking about inverses, you swap your x with your y values, your domain with your range. They become interchanged. The domain becomes the range, and the range becomes the domain for the inverse. So in general, if I have some f inverse, and I apply the original function to it, okay, then my output is going to be x. And if you want to think about it this way, say I had some function that takes a number and it doubles it, okay? So say I have a function and like I input 2, or say I input 3, okay? What's the output going to be? If it doubles 3, it's going to make it to 6, right? So the question becomes, well, what do I have to do to 6 to get back to 3? So the inverse function, f inverse of x, to get from 6 back to 3, well, I got to cut 6 in half. So I'll do 1/2 x. Okay? So if you take this scenario here, I have f of f inverse. What is f inverse? That's 1/2 x. Well, what is f of something? F of something equals 2 times something, right? So this is 2 times, well, what is my something here? It's 1/2 x. So what happens here is the 2 and the 1/2 cancel and I just get x. So this is a definition in general here. F of f inverse outputs your original x. It's like I put 1 foot in, then I put 1 foot out, and you shake it all. Oh yeah, whatever. Okay. Yeah, I know I'm crazy. All right, anyway, it's like I'm literally making full circle and going right back to where I started whenever I do f of f inverse. Okay, I get right back to x. So that was the point I was trying to make there. So it works that way where f is on the outside here. It also works the other way where if I have f of x, if I do f inverse applied to f of x, I still get the same thing, I get x. So this is in general. So if you want to verify that if f inverse is the inverse of f, this is how you do it. You combine, do a composition of functions both ways, and if they both give you an output of x, then that shows that you have an inverse function. Now, well, since this is not college algebra, this is calculus, we're going to talk about taking derivatives of inverse functions. So derivatives of inverse functions is f is differentiable and 1-to-1. So we need it to be differentiable. We also need it to be 1-to-1. Okay? If it's 1-to-1, we know the inverse function is a function, or the inverse is a function, right? Now, what do we know? If I can take the derivative, then f inverse of b, its derivative, is 1 over f prime of a. Okay? And f inverse derivative is 1 over f prime of g of x. All right? Where, you have f of g of x, right? So let's work through that. See if we can't figure out, what that's even saying, right? So let y equal f inverse of x. Then what can I do? I take the derivative of both sides here. I'm sorry, I'm gonna apply the f function here. If I apply f to this, f and f inverse are going to cancel each other. So I have f of y equals x. Now I'm going to take the derivative of f of y and x. So the derivative of f of y is equal to, well, since y is different than x here, I have to treat it like a chain rule. So the derivative of f of stuff is f prime of the stuff times the derivative of the stuff. Derivative of y with respect to x is dy dx, or y prime. Okay? Now the derivative of x is just 1. And if I'm going to solve for the derivative here, dy dx, I need to divide both sides by y, or f prime of y. And so when I do that, I get 1 over f prime of y here. So this is where this formula comes into play. Because y is equal to f inverse. And so it's 1 over the derivative of f with f inverse in the argument. All right.